Hello and welcome to Algebra 1, Lesson 53. In this lesson, we're going to learn about the distance formula. So we just got done talking about square roots, cube roots, fourth roots, basically radicals in general. Now, one of the immediate applications of square roots would be the ability to find the distance between 2 points on the coordinate plane using the Pythagorean theorem, or your book might say the Pythagorean formula. So the Pythagorean formula basically looks like this. You have this a squared plus b squared equals c squared. It's a pretty famous formula. So even if you haven't taken geometry yet or you haven't seen it in a previous algebra course, you've probably come across this at some point, okay? So what the Pythagorean formula does is it tells us about the relationship between the sides in a right triangle. So I alluded to geometry, and I know that some of you probably haven't studied geometry yet because this is usually taken directly after an Algebra 1 course. So if you don't know anything about triangles, it's not a big deal. You can pick up what you need to know about right triangles from our lesson today. So let's focus on what we have here, this triangle. See a lot of stuff that's labeled, and let's just kind of go through that. So the first thing is you'll notice that this symbol here is going to denote that we have a 90-degree angle, or what is known as a right angle. Okay, so when a triangle has a 90-degree angle or a right angle, it is known as a right triangle. Okay, a right triangle. Now, with a right triangle, you have two shorter sides that are known as legs. So here you have this leg A and this leg B. Okay, so those are the two shorter sides of the right triangle. Then the longest side is always going to be opposite of the 90-degree angle. So opposite of that would be here. That's labeled as C, and it's known as the hypotenuse, okay? So the way the Pythagorean formula works is it tells us that kind of the measure of leg A, so from here to here, if we square that, so that's where you get the A squared, then plus the measure of leg B, so from here to here, so you take that and you square it, so you're summing those two amounts together, so A squared plus B squared, this is equal to C, or the hypotenuse, squared. Okay, so this is true for any right triangle that you work with. Now, what we're going to see is that we can use this kind of Pythagorean formula to develop a distance formula that's going to tell us the distance between 2 points on a coordinate plane. But before we jump into that, let's look at a little sample problem just to get our feet wet. So when we're using our Pythagorean formula, if two of the three sides are known, we can solve for the third side that is unknown. So in this case, we're given that A is 3, so that's going to be from here to here. Okay, that's my leg A. B is 4, so that's going to be from here to here. Okay, so that's my leg B. We want to know what is C. C is from here to here. That's our hypotenuse. Okay, so all I need to do is plug into my Pythagorean formula, and I can crank out an answer. So I have A squared plus B squared equals C squared. Okay, plug in for A. What is A? It's 3, so just plug that in there. What is B? That's 4, so just plug that in there. So 3 squared is 9, plus 4 squared is 16. This equals C squared. I'm going to flip this around just so I have my variable on the left side. So I'm going to say C squared equals 9 plus 16 is 25. Okay, so we haven't solved something like this yet, and we're going to get to this as we kind of progress through our course. But essentially what I want to do, if I want to isolate C, since it's being squared, I want to take the square root of each side, right? I'm always thinking about how can I undo what's being done to my variable, right? So since C, the variable I'm trying to solve for, is being squared, to undo that, I just take the square root, okay? And to make it legal, I've got to take the square root of each side. So let me kind of scooch this down just a little bit. So I would take the square root of this side and the square root of this side. Now, in most cases when you do this, you want to go plus or minus over here. Okay, in this case, you're not going to, and I'll explain why in a second. First, let's kind of solve just given the way that I've presented it here. So this index of 2, right, remember this square root has an index of 2, is going to cancel with this exponent of 2. Okay, so I now have C by itself, and it's equal to plus or minus the square root of 25, which is 5. Now, does that make sense? Well, remember, if I erase all this, and I bring this back to C squared equals 25, well, C could be 5, right? 5 squared is 25. And c could also be -5, right? -5 squared is 25. So that's why you have that little plus or minus there. And we'll get to that later on in the course as to why that's important. But for now, we just take it as a given. But we need to understand that here in this specific situation, I don't need a -5 as an answer. I only need the principal square root when I do this because 5 is my only valid solution. Why? Because I'm thinking about how far is it from here to here. I'm basically thinking about the distance or the measure of c, and that's not going to be negative, right? -5 is a nonsensical answer. It can only be +5, okay? So we've seen an example of working with the Pythagorean formula, and now we're going to use it to find the distance between 2 points on a coordinate plane. Essentially, you're going to have a point that's here and here, okay? And what we're going to do is we're going to derive a formula that lets us solve for the unknown, which is going to be the hypotenuse, given the fact that we're going to be able to find this horizontal distance here and this vertical distance here. So what we have on the screen here is our distance formula. Again, the distance formula is just allowing us to easily calculate the distance between 2 points on a coordinate plane. It's a direct application of what we're just looking at, again, the Pythagorean formula. So what we see here is that d, which stands for distance, is equal to the square root of, we have x sub 2 minus x sub 1 squared, plus we have y sub 2 minus y sub 1 squared. And again, just like when we worked with slope, okay, we can label one of our points as x sub 1, y sub 1, the other as x sub 2, y sub 2. It's not going to matter which is labeled as which. You're going to get the same answer either way. So how does this relate to the Pythagorean formula? Well, let's look at an example and work through that completely, and then we'll kind of bust through a bunch of examples. All right, so we want to find the distance between each pair of points. And we're going to start out with 5, -2 and -7, -7. So let me go back up. So we have 5, -2, and we have -7, -7. So the first thing I'm going to do is just plug into the formula. We're going to get an answer. Then we're going to go to the coordinate plane. And I'm going to show you where this comes from. So d, the distance, is equal to the square root of. So I'm going to label this guy as x sub 1, y sub 1. And I'll label this as x sub 2, y sub 2. Again, you can change that up. It wouldn't matter. So x sub 2 is going to be -7. Just plugging that in for x sub 2 there. Then minus x sub 1 is going to be 5. Just plugging that in there. This is squared. Then plus, we've got y sub 2, which is -7. Just plugging that in for y sub 2 there. Then minus y sub 1, which is -2. Be careful. You're going to have minus a negative, which is plus a positive. So this is going to be +2. And then this guy is squared. So all I did was I plugged in. Okay, nothing fancy there. So my distance, d, is going to be equal to the square root of, all I've got to do is just kind of crank this out. -7 minus 5 is going to be -12. -12 squared is 144. Then plus, -7 plus 2 is going to be -5. -5 squared is 25. So 144 plus 25 is 169. So d, my distance, is going to be equal to the square root of 169, which is basically 13. Right, so let me kind of erase this, and I'll say the distance between the 2 points is going to be 13. Okay, so where did this come from? I know most of you just want to be able to get through your homework, so once you have the formula, you're basically good to go. You can just plug in, but I want you to understand where it came from. So let's go to the coordinate plane, and let's think about the distance between the 2 points kind of using a different approach. So again, we had 5, -2, and we also had -7, -7. So I've kind of pre-drawn everything to make this a little faster. So we have 5, -2. That's right here. Okay, that's your 5, -2. And then you have -7, -7. So that's going to be right here. So you'll notice that I drew in an extra point to kind of form the right triangle. So the way I did that was I took the x coordinate from here, which was 5, and I took the y coordinate from here, which was -7. That gave me my third vertex. So I could, again, draw the right triangle. So what I can see is that I can find the measure from here to here. That's going to be a vertical leg for me. That's going to be my leg A. I can find the measure from here to here. That's going to be my horizontal leg, or my leg B, okay? And all I need to solve for is this C, which is the distance between these 2 points. That's my unknown, okay? So how do I find the measure for leg A? Well, since this is a vertical line, I'm just thinking about y values, okay, because it's parallel to the y-axis. So how far do I move from this y-coordinate here of -7 to this y-coordinate here of -2? Well, most of you would realize that you just need to subtract the y values, right? So you would just basically do, inside of absolute value bars, -2 minus a -7, which would be equal to what? it would be the absolute value of negative 2 plus 7, which would be equal to the absolute value of 5, which is 5. You could also do it the other way because you use absolute value. So I could reverse this completely, and I could say that we had negative 7 minus a negative 2. Okay, you get the same answer. So negative 7 minus a negative 2 inside of absolute value bars would be the absolute value of negative 7 plus 2, which would be the absolute value of negative 5, which would be 5. Okay, now you might say, well, why are you using absolute value? We're using absolute value because we're calculating a distance, and we don't want to end up with a negative value. Okay, so notice how we just found the difference in y values. Now, if we go back up, you'll notice that when we did our formula, we have y sub 2 minus y sub 1. We're just calculating the difference in y values. So we're doing the same thing. We don't have absolute value bars because we're squaring the result. Okay, so if you square something that's negative, if I ended up with negative 5 and I squared, I get 25. If I end up with 5 and I squared, I get 25. So I don't need absolute value bars. So that's why they're not there. The same thing is going to go when I find the kind of horizontal legs measure. So now I'm dealing with a horizontal line, which is going to be parallel to the x-axis. So I'm thinking about x values now. So I have an x value of negative 7, and I have an x value of 5. So I can either do the absolute value of 5 minus a negative 7, or I could do the absolute value of negative 7 minus 5. Gives me the same answer either way. So this would be equal to what? This would be equal to the absolute value of 5 plus 7, which is 12. So the absolute value of 12 is 12. Okay, so again, if I go back up, I'm looking for the difference in x values. And again, if it's negative 12 and I square it, I get 144. If it's positive 12 and I square it, I get 144. So I don't need absolute value bars in that case. Okay, so once we know that leg A's measure is 5 and leg B's measure is 12, well, then I can plug into my formula, right? So I can say that this is A. So 5 is A, and we're squaring that. Plus the B is going to be what? It's 12, so we're squaring that. This is equal to C squared, okay? C squared. And in this case, we just relabeled C with D for distance. That's all we did. So let's just label this as D. It doesn't matter. We're just changing the variable's letter, but it means the same thing, okay? So if I have D squared equals 5 squared plus 12 squared, how do I solve for D? Well, at this point, I could just take the square root of each side, right? I know I can simplify this further, but all I'm doing up here, if I go back to my formula, once I have this guy, I can just take the square root of each side, and I've solved for D. Okay, let me go back down, make that crystal clear. So D squared equals, you have 5 squared plus 12 squared. If I take the square root of each side, then this would go away, and I have the square root of this. Then I could just calculate this. 5 squared is 25. And 12 squared is 144. And then 25 plus 144 is 169. And we all know the answer from earlier, D equals square root of 169, which is 13. Okay, so just a quick insight into where this comes from. It's a direct application of the Pythagorean formula. I know most of you, you're more interested in just being able to kind of get the formula and crank out your homework. But it's nice to know where it comes from. In case you forget the formula, you can kind of pull out a coordinate plane and kind of think your way through deriving this formula because it's very easy to get. You just need the difference in x values squared plus the difference in y values squared. That gives you your a squared plus b squared, okay? And you set this equal to c squared. And from that, you can kind of set up your distance formula. All right. So now let's kind of wrap up the lesson by just kind of bursting through a few of these. Once you know the formula is very, very easy. So we have that the distance between 2 points is equal to the square root of, you've got x sub 2 minus x sub 1 quantity squared, plus you've got your y sub 2 minus your y sub 1, that quantity squared, okay? And I'll just drag this down here. And let me put that right there. So this is going to be my x sub 1, y sub 1. This is going to be my x sub 2, y sub 2. Again, you can change that around. It doesn't matter. So just plug in real quick. We'll get our answer. So x sub 2 in this case is going to be 6. And x sub 1 is going to be negative 3. Minus the negative 3 is plus 3. Be very careful when you work with these. Whenever you have minus a negative, you've got to make sure you do plus a positive. Okay? A very common mistake. So then y sub 2 is going to be negative 6. And y sub 1 is going to be positive 6. So 6 plus 3 is 9. 9 squared is 81. And negative 6 minus 6 is negative 12. Negative 12 squared is 144. So you get 81 plus 144, which is going to be 225. And the principal square root of 225 is 15. So the distance between these 2 points is going to be 15. All right, let's take a look at another one. So we have d, the distance between the 2 points, is equal to the square root of. You've got your x sub 2 minus your x sub 1, that quantity squared, plus your y sub 2 minus your y sub 1, that quantity squared. And let me kind of make that a little bit better. Okay, so let's just change it up and label this as x sub 2, y sub 2. We'll label this as x sub 1, y sub 1. Again, it does not matter how they're labeled, just like you saw with slope formula. So for x sub 2, I'm going to erase this and put 8. For x sub 1, I'm going to erase this and put 7. You can go ahead and do that. 8 minus 7 is 1. 1 squared is 1. Okay, so that's pretty simple. For y sub 2, I've got a 1. For y sub 1, I've got a negative 3. So again, be careful. Minus a negative 3 is plus 3. And 1 plus 3 is obviously 4. So if I have 4 squared, that gives me 16. 1 plus 16 is 17. So d, the distance, is equal to the square root of 17. Now, 17 is not a perfect square, and 17 is a prime number, so it's not going to factor, right? It's just 1 times 17. So when you get an irrational number for your answer, then what you want to do is either leave it as the square root of 17, or you can approximate it if you want to. But make sure you use the correct symbol because it's not precise. So we could say d is approximately 4.12. Okay? It's approximately or about 4.12. Again, this is precise. D is equal to the square root of 17. I would always go with this answer, but sometimes it makes sense to do this, especially if you need to do some more calculations with it. All right, let's finish up the lesson and just look at one more. So we've got d, our distance between the 2 points, is equal to the square root of. Again, you've got your x sub 2 minus your x sub 1 squared. Let me make that a little better, a little clearer. Plus, you've got your y sub 2 minus your y sub 1 squared. And let me make that a little better. Okay, so I'll label this as x sub 1, y sub 1. And this is x sub 2, y sub 2. And again, we're just going to plug in. So for x sub 2, I'm going to plug in a 5. For x sub 1, I'm going to plug in a negative 5. So minus a negative 5 is plus 5. So 5 plus 5 is 10. 10 squared is 100. Okay, so this is 100. And then y sub 2 is going to be 4. And y sub 1 is negative 3. Again, minus a negative 3 is plus 3. So 4 plus 3 is going to be 7. 7 squared is 49. Okay, so now you've got 100 plus 49, which is 149. Okay, 149. And again, 149 is a prime number. So I'm just going to leave my answer like this. I'm just going to say d is equal to the square root of 149, just like that. If you want to approximate it, you can. You can say d, the distance, is approximately going to be 12.21. Okay, just as an approximation. But this guy right here is a precise answer, whereas this one is just an estimate.